Stevens Hall, arguably the most important of UL's data centers. Stevens Hall is the center of student life at the university. It houses Moodle, Zimbra, and ISIS. These systems are central to students and cannot be allowed to fail under any circumstances. Even understaffed, the Stevens Hall crew manages to maintain the data center with only a 1-hour weekly time frame for maintenance. Our walkthrough yielded impressive results of their already robust systems, but like everyone else, there's room for improvement. From backups and hardware to cooling and security, Stevens Hall is prepared for any circumstance. But we learned their methods, and we studied their layout. This is what we found.
The Stevens Hall current air conditioning setup is handled by 4 AC units that are spread throughout the data center. There are 2 behind the server racks, which are facing the hot air exhaust of the servers, 1 on the far end of the room, near the tape storage, and a 4th in the networking room. These 4 crack units, or computer room air conditioning units, suck in hot air from the room and feed cold air into the raised floor. The floor has vents placed at locations near servers and other heat-producing equipment in such a way that they immediately take in this cold air. This way there is limited waste where cold air is considered. These units operate solely in the data center and are separate from the chillers that take care of the rest of the campus. The main issue with cooling in the data center is the mixing of the hot and cold air. This makes it difficult for achieving optimal temperatures for maximum efficiency from the crack units. These units perform best with the temperatures at its highest potential point. However, this is not an ideal situation for the servers since they need cool air to keep from overheating. The best solution for this would be to use cold aisle containment, which is essentially creating a sealed room in the aisles between the server racks. This would allow for cold air to be contained directly in front of the server racks for optimal intake, and allow the remainder of the room to be filled with the heat exhausted from the racks. This would allow the crack units to perform as efficiently as possible. Unfortunately for Stevens Hall, there are not enough server racks present to realistically implement cold aisle containment. In the future, when the second row of server racks comes into use, we recommend implementing cold aisle containment to fix these heat issues. Due to the amount of cooling present, this is not an immediate concern though. For the time being, with the current setup, we would recommend implementing a roof between the server rack and existing racks on the opposite side of the room. This would prevent any heat from sinking below the top of the racks and being sucked into the front of the existing servers. This would optimize the current setup and be easy and affordable.
Power in Stevens Hall is used by support equipment and mainly consists of cooling systems, power delivery, and other facility infrastructures, such as lighting. Each rack has 2 power feeds, one which comes directly from the mainframe, LUS, and one that comes from an uninterruptible power supply. For redundancy needs, Stevens Hall has 2 switches on top of the racks which control the flow of power. This ensures that a failure in one of the power lines does not cause any problems. In the case of a power outage, Stevens Hall has power backups that will allow for enough time for all of the data to be saved and the machines to be shut down properly. Stevens Hall consumes a large amount of power, considering that it is pretty fair in size. Ignoring the amount of floor space, Stevens Hall could use a per rack power consumption model to record exactly how much power is coming from each rack. A handful of servers can be put in each rack, leaving the rest of the rack empty. This would create a lower power density in each rack. Using the detection of how much power there is per rack, Stevens Hall can distribute power accordingly.
There are currently 8 singular racks, 2 groupings of 4, which are being utilized in Stevens Hall and contain some major infrastructure. These racks house their Linux and OSI environments, as well as the majority of the storage for the university. Each rack has a set of networking switches at the top, which feed into the individual blades below. There are also 2 sets of power lines that run into each rack, one being from the UPS backup, the other from the main power line. The cable management inside the racks is almost ideal. the only cons being extra cabling and parts laying on top of some of the blade stacks. The cable lines run from the back of the blades to the front and are then guided upwards using Velcro ties to a main overhead track system. The tracks guide the lines out of the main room and over to the networking room. Other than removing the spare parts and tying back the extra cabling, the rack setup is ideal. As shown, there are some racks which could use some rearranging as well as more spacing for better airflow. Once the second row of racks is added, this will allow for some blades to be moved to separate racks, thus more spacing.
The day-to-day operations in Stevens Hall are pretty standard in terms of an IT branch maintaining servers and systems. Around 60% of the team is help desk and spends their days answering support calls and creating and subsequently closing tickets. The other 40% are in charge of server maintenance and the issuance and retirement of servers. In charge is Patrick Landry, their lead system architect. The department is in charge of provisioning new systems and implementing all the software and servers the other departments on campus need. All these new systems and software, as well as any changes made to them, are documented in a wiki that belongs to the whole department and is updated manually on an as-needed basis. In addition, many configuration files and other important files are version controlled using Git to make sure no potentially disastrous changes cannot be reverted. Policies and procedures are your run-of-the-mill IT security protocols and HR management forms. The largest issue with Stevens Hall operations was the way it managed internal change. Despite its version control processes and its comprehensive wiki of systems, we feel that the ticketing system for internal tickets would really benefit the department in terms of accountability, as well as ensuring documentation gets updated through some sort of workflow management system. Also, while Stevens Hall is able to integrate new employees into the department, they lack official documentation to be provided to employees and administration whenever they're hired. We would recommend that an official employee handbook be created to be provided to each new employee on their hire date. This handbook should be updated each year with new policies and procedures as they are implemented. This will help to standardize their daily processes and maintain consistency among the employee knowledge base. In addition, we feel it would be beneficial to segregate tickets into teams with specific skill sets. That is, the current ticketing system puts all tickets into a pool, and any employee is able to be assigned any ticket. Efficiency and quality of help desk could be improved if the employees were split into teams based on their abilities, and tickets requiring specialized knowledge would be designated to their respective teams. Another simple implementation could be a dashboard for end users to display the current status of university systems. For instance, the dashboard might display Zimbra, Moodle, and the status of the student portal. Then, if a system was unresponsive or down, a student or faculty member could look at the dashboard and tell, at a glance, whether or not the issue was on their end or on the server side.
As we've shown, Stevens Hall has a very robust system, but like anyone else, they have room for improvement. We've suggested a cold aisle containment system for separating hot air from cold air between racks. We've also suggested they revisit their cable management, as currently cables are just thrown where they lie. We suggest they bundle light cables and hang them from the racks as intended. We've also suggested a dashboard so that they can view the status of their various data loads and services. Currently, their wiki documentation is lackluster, so we've suggested they revamp their documentation into something more official and up-to-date. Furthermore, while Stevens Hall has a hardware replacement cycle in place, they do not follow it, so for obvious reasons, we've suggested they follow their replacement cycle. We've also suggested they designate teams for internal ticket support so that they can manage their internal tickets the same way they would manage external requests. Furthermore, we've suggested digital, cloud-based backups on Amazon Web Services. They could also automate these backups so that they do not have to worry about the backup process. And finally, we suggested a warm room for disaster recovery purposes, so that they will need to spend less time migrating servers to a new environment in case of a disaster.